As I was working today, my mind began to wander, as it does, and I found myself thinking about the interior of our planet. And it occurred to me that if you go down deep enough, it wouldn't be dark. I mean, it would be dark in the sense that you wouldn't be alive to see it, but if you were in some kind of transparent sphere that could not be crushed or melted, but was see-through, once you got deep enough, it would start to get brighter and brighter and brighter until you were right next to the inner core, and it would be actually quite bright. You might even need sunglasses at that location. And it's kind of interesting to think about because the inner core is like what, 5,000 degrees Celsius, maybe 5,500, somewhere around there. It's roughly the same temperature as the surface of the sun, and the sun is quite bright. That's a function of just matter. If you heat it up enough, it'll start to emit visible light. And the outer core is like 6,000 degrees next to the inner core, and about 3,000 degrees near the mantle. And they're both iron nickel. I know the inner core is probably iron nickel alloy, and the outer core is probably an iron nickel fluid. But yeah, it would be very bright. Like, think about a metal foundry. You look at molten iron, and it is very bright. And the more heat you pump into a metal, the brighter it gets. Lava's pretty bright, and it's molten rock. So this 5,500 degrees Celsius iron nickel ball at the center of the Earth, if you could like remove it and just kind of have it out in space in orbit of Earth, just by itself, it would be incredibly bright. It would be brighter than the moon. At that distance, it would probably be brighter than the sun. Maybe. It depends on how close it was. The sun would outshine it, obviously, if it was, at the same distance. But if you were like to take a square meter of Earth core and a square meter of sun and held them at, like, the same distance, it would probably be roughly the same visible brightness. However, I would assume the sun is brighter overall, just because of sheer size and energy. But, there is math there, I don't know it. That's just conjecture, don't hold me to that, but point is, the inner core is quite bright, and the outer core would be quite bright. I wonder how bright the mantle would be. I'm not actually sure. I mean, I know there are layers when the mantle would be glowing red or would be molten, so I assume once you get past, like, the moho disturbance underneath the crust, whatever it's called, you would start to have glowing rocks that would start to be visible light, and then once you got to, like, midpoint through the mantle, yeah, things would be glowing around you. It would be red, be hot, be molten. The mantle's a weird place. It's kind of a weird hodgepodge of solid and liquid. It's just a lot of stuff. But, yeah. Interesting. So, the crust is the only place you're going to find darkness, really. If you think about it. Because if you're outside the crust, the sun's shining on you. And if you're under the crust, the earth is glowing at you. There's no point to this video. I just thought that was interesting.